Hey guys, welcome back. This time around we're going to continue our discussion on the language of chemistry. And we're going to attempt to decipher the periodic chart and identify those key things that we need to be able to recognize from any given element that we might find on a periodic chart. Now if you remember from our previous discussion, each of these individual blocks represents a different element, and each element is going to be represented by a letter or two letters. Now remember, the smallest unit of an element is known as an atom. And for that reason, we typically use the word atom or atomic to describe the things that we would find in the box about each element. From the last discussion, we found out that those letters that represent the element are called the atomic symbols, if you recall. This time around, we need to see what those numbers represent. And to do that, we need to discuss what an atom is and what makes up an atom. An atom is composed of subatomic particles. There's three types of subatomic particles. There are protons, there are neutrons, and there are electrons. And each of those three, we can determine how many protons, how many neutrons, and how many electrons there are in a given element simply by looking at the periodic chart. But first, let's decipher what are the difference between protons, neutrons, and electrons. One of those things is location, where the subatomic particles are found within the atom. Protons and neutrons are going to be located in what's known as the atomic nucleus. Now, the atomic nucleus is just a centrally located area. It is not enclosed by a membrane or anything like the cell nucleus would be. The electrons, on the other hand, are going to be orbiting around the atomic nucleus in what we would call energy levels or energy shells. The charge is another thing that's going to differ between the three. Protons have a net positive charge. For each proton found in a given atom, you're going to have one net positive charge associated with that atom. Neutrons are neutral. They have no charge. And electrons are negatively charged. Now let's think about those electrons. We hear a lot about electrons, electricity, electronics. That's all built around this concept of electrons. Now let's also then finally say size. The third thing that differs between these three subatomic particles are their mass. So for each proton I have one atomic mass unit. So if I have an atom that has 6 protons in it, then it has 6 atomic mass units, or AMUs. Another name that's frequently used for AMUs are Daltons. So 1 AMU equals 1 Dalton. For each neutron that I have, I'm going to also have 1 AMU. So if I have 6 protons and 6 neutrons in a given atom, then that would be equivalent to 12 AMUs. Electrons, on the other hand, have no net mass. In comparison to protons and neutrons, it's negligible. So we don't usually take into consideration electrons when we look at the overall mass. How can I determine the number of protons found in a given element? That goes back to those numbers that are found in the element. Let's use carbon as our example. If you take a look at the box that has all the information that represents what is carbon on a periodic chart, you'll see that you have the atomic symbol there. You'll see that you have two numbers there, one a 6 and the other one's going to be a 12.011. Now what are those two numbers? Well, those two numbers are going to be, the 6 will be representative of what's known as the atomic number, and the 12.011 is going to be what we would think of as the atomic weight. Now look at those three phrases of three things that are identified on the periodic chart. What do they have in common? All three of them have the first word, atomic. So if it's found on the periodic chart, it's atomic something. Now let's look at that atomic number. Atomic number is going to be equal to the number of protons that every atom of a given element has. Look at carbon. That means that every atom of carbon has 6 protons. Now what happens if an atom of carbon gives up a proton? Is it still a carbon atom? The answer there is no. It now has the atomic symbol, atomic number of 5. What happens if it gains a proton? Is it still going to be an atom of carbon? The answer there, I hope you say, is no, because when you add a proton to an atom of carbon, you may convert it into an atom of nitrogen. There you go. So now look at your periodic chart and tell me, is there any two elements on the periodic chart that have the same atomic number? I hope you say no. Because notice you can start with hydrogen, go to helium, come back to lithium, beryllium, and move across to boron and carbon and all those things. And notice that you read the periodic chart from row to row, and that what differs and what determines the organization of the elements on that periodic chart is one, the number of protons that are given in each atom of a given element. Now, another neat thing to understand about the periodic chart is that, as read from the periodic chart, every element is electroneutral, has no net charge. Now, we just looked at the atom of carbon. It has 6 protons. We just discussed a moment ago, protons come with positive charge. For every proton I have 1 positive charge. So that means I have 6 positive charges in every atom. Yet every atom of carbon, as read from the periodic chart, is electroneutral. What is the subatomic particle that carries a negative charge? Electrons. Now, while electrons are quite small in size, they still carry an equal yet opposite charge to our protons. So if I have 6 electrons along with 6 protons, then I have an electroneutral carbon atom. And as read from the periodic chart, carbon is electroneutral, which means that if it's got 6 protons, it must have 6 electrons. Now take a look at hydrogen. From this discussion, could you tell me, by looking at the atom of hydrogen, how many protons it has? How many electrons it has? How many positive charges it has? How many negative charges it has? I hope so. Now look at oxygen. Could you tell me how many protons it has? How many electrons it has? How many positive charges it has? How many negative charges it has? Notice that from any element, if I gave you the element or the atomic symbol, and you had a periodic chart in front of you, and as I promised you, you will on a test, you could tell me the atomic number, the atomic symbol, the number of protons, the number of electrons, the number of positive charges, and the number of negative charges straight from that chart. What's left to learn? The number of neutrons. How do I determine the number of neutrons? Well, you determine it from that other number. It's 12.011. That 12.011 is the atomic weight. Now, the atomic weight is going to be the average weight of any sample that I look at when I'm measuring a sample of carbon. Now, the problem with elements are every atom of that element does not have the same number of protons and neutrons in it. Because remember from our previous chart, the 2 subatomic particles that carry a mass are protons and neutrons. If every atom of carbon had the same number of protons and neutrons in it, then this would be a whole number for its weight. But the atomic weight is actually an average of all the different forms of atoms of carbon times the frequency at which they occur in nature. So we aren't really going to delve into the textbooks and try to remember charts. What we're going to do is say that we can actually find a number of neutrons found in the most common form of carbon. And we can do that by taking the atomic weight and rounding it off to the nearest whole number. In this case, it'd be 12. When you round it off to 12, that is going to be the mass number of the most common form of carbon. Notice mass number does not have atomic in it, and that is because it's not found off the periodic chart. We have to actually get it by rounding off the atomic weight. But the mass number is going to equal the most common form of carbon. Now, another name for form is isotope of carbon. Now, it's going to be a carbon-12 isotope. It's written as a superscript here. Now, what does that mass number tell me? Well, the mass number is going to be equal to the number of subatomic particles that have mass that's going to be found in that atom. The 2 subatomic particles that have mass are protons and neutrons. So if I know the overall mass, 12, and I know the number of protons, can I solve for the number of neutrons that are going to be found in the most common form of carbon? I can, by simply taking the mass number and subtracting the number of protons, because the number of protons are always going to be the same in carbon. Now go over and look at oxygen. Oxygen has an atomic symbol of O, has the atomic number of 8, and it has the atomic weight of 15.99. Round off to 15.99 to the nearest whole number, you get 16, right? That's the mass number, the most common form, correct? And the mass number is going to be equal to the number of protons plus the number of electrons found in that element, or that atom of that element of oxygen. Correct? So how many neutrons are found in the most common form of oxygen? Should tell me 8. Now let's do nitrogen. And this time around, I'm going to ask you, what's the PEN? P-E-N. Protons, number of electrons, and number of neutrons. Then you can always tell me the number of protons because it's atomic number, right? You can always tell me the number of electrons because, as read from the periodic chart, every element is electroneutral. And you can always tell me the number of neutrons found in the most stable form, right? So what is the PEN? Let's do it for calcium. And let's do it for magnesium. Now notice you just discovered not only that there are 3 subatomic particles that are going to be found that make up every atom, but you've discovered that you can identify how many of those subatomic particles are going to be found in each given element. You can tell me, atom of the element, you can tell me how many positive charges there are in an atom, and thus how many negative charges there are in that atom as well. Come a long way in a short time, but now it's time to reflect a little bit. Go back, take a look at the terminology that we began with, energy and the forms of energy, the types of energy, what matter is, and go back and take a look at how we described elements, how we described atoms, what subatomic particles are now, what the different types of subatomic particles, and how we can get them from the periodic chart. Now I got a question for you. Your mother always tells you to make sure you take your vitamins and your minerals, because apparently vitamins and minerals are very important to a growing child and somebody even my age. Are the elements off the periodic chart, are they either vitamins or minerals, or are they both? Great question. Have a good day. Enjoyed talking to you.